So when I was in graduate school, there wasn't very many good videos on spectral sequences, and I mean there's actually none. And when you Googled it, or when you went on YouTube, you found this like really bizarre video of this guy, I think with like a mutated voice, and then there was some like really weird artsy thing with weird numbers in the background. I don't know. I'm gonna try and find it and link to it if I can find it. If it's still there. Okay, that being said, I'm going to make a little video on spectral sequences because I want to use them. And let me just say what they are. So, so the input... Okay, so first I need to say what they do for you. And what they do for you is if... Okay, so if the input is a complex... and then a filtration on the complex. F. And so we'll assume that this is a decreasing, meaning that Fi will be, Fi plus 1 will contain Fi. Okay, for all the i's. So it gets bigger and bigger, and it's for each one of these. And then the output will be, well, the output is kind of part of the input, but what the first output is a filtration, an induced filtration on the cohomology. And so maybe we can call this F induced. And then the other part is what it gives you is a formula, a nice formula for the graded pieces of associated induced filtration, of the associated induced filtration on H bullet K star, I guess. I'll do it like this. Okay, so anytime you have a filtration, you have these associated graded, and then maybe we can put as a bonus is this a low degree exact sequence. Okay, so for the low degree exact sequence, I'm going to defer to another video, and I'm going to do some examples of where this is useful. But first, I want to say that even when you write down a spectral sequence, so what does the general shape of a spectral sequence look like? So the general shape of a spectral sequence. Okay, I'm going to write it down like how you're not going to be used to it first. I was deciding whether I should do it the way that you've seen it before or the way you haven't seen it before. But let's do it the way you haven't seen it. Oh, so it says that, so what we'll do is we'll take H and K bullet. So we have this complex with this filtration. And then what it says is that the graded piece, the ith graded piece, so this is going to be equal to E I n minus I R. So this is when it converges at level R. So this is saying converges at level R at rth page, let's say. Okay, I haven't said what a page is, but these will be a sequence of objects. And then usually, this is usually equal to something explicit. And so it's useful. Okay, and let me just say what this thing is. So this is the associated graded. So this is the associated graded to F induced. Okay, and so this thing is equal to F induced I of HNK bullet modulo Fi plus 1 induced of HNK bullet. Okay, so this is kind of this general shape here of what these things look like. So what they'll end up doing is so like you have your cohomology, you have some filtration. The filtration gives you an induced filtration on cohomology, and then you can look at the associated graded pieces, and then you have something explicit that tells you what these things are. So for example, like if you know that these are all 0. You'll know that the original thing, the whole cohomology is 0, so that's nice. So, for example, you can determine. Or if these are vector spaces, you can determine the dimension of this vector space if these things are known. Okay, and so how these things, these pieces of these pages are actually going to be determined from other cohomology sequences. By the way, if you hear some knocking, it's because someone next door is doing some work or something. I don't know. They've just been like hammering on the wall all day. I have no idea what's going on. Okay, so let me say again. Let me just make what these associated graded things clear, in case this isn't clear. So I guess I talked about the associated graded things. I should make. So I have this thing. Okay, so I talked about the associated graded. I want to make some observations, just quick observations about filtrations. Okay, so first, that if I have a filtration, so let's take K bar to be a complex. So this is going to be a complex in an abelian category, and then F is a increasing filtration. Okay, what we require, okay, and this is going to be, we're going to be with map D from Ki to Ki plus 1. Then what are we going to have? So this will be like, this is a bunch of these things. So this is a bunch of maps like this. Okay. Okay. So, or let me use another letter. J or something. Okay, maybe that's not a best letter either, but okay. And then this thing always satisfies, when you have this thing, it always satisfies that D F J of Ki is going to be contained in F J Ki plus 1. Okay, so this means that this guy, Fj of K bullet, is a subcomplex. A subcomplex. Okay, I want to say something else. The other thing that I want to say is that, so this is first thing I wanted to say. The second thing that I wanted to say is, maybe I should put that in parentheses, was that here, so we have this graded piece, let's say the pth graded piece of K bullet is equal to F P K bullet minus F P plus 1 K bullet. Okay, and so this means you do this for all I, do the quotient for all I. So you replace all the bullets with I's. And then you can look at this thing, and actually, you can just check really quickly that this thing here, I to, if I do D P Ki plus 1 is well defined. So what will happen is, so this implies that this thing here, graded piece and then K is a complex. Okay, so you can take these filtrations like this, and then you can get this new complex, which is the graded the pith graded version of the complex. And I should note that I guess I should have done this instead of doing it like this. Since they're two different objects, so I should take the ith. So I take the graded thing of this, and I take the ith part. So this is, I guess, the same thing if you did the. Okay, so I was viewing this as a graded object, but I guess what I wanted to say is that the graded piece of HN K bullet of, if I take this grading and then I take the ith piece, this is the same thing as if I take the ith piece of the graded complex. Let's see. No, this is not true. This is not in general. Well, we don't know that this is equal to. It's not clear that this is equal to this thing here. Okay, so that's what the remark I wanted to make. Okay, so this is not clear. And I think it's not true. Okay, so I'm going to do the outside notation for the associated graded thing. Okay. Right, we have these graded things, and now so I kind of want to explain what the EIJs are. First I wanted to do an example. So let's do an example where we like to show the setup, or show how weird it can be sometimes. So for the Hodge filtration, so if we take, this is for a map of schemes. And for this to converge, let's say everything's in characteristic 0. So maybe this could be a morphism of varieties over C. But what this says is that E1, so let's take this thing. Let's see, do I want to write it in my way or the other way? So how did I write it before? Okay, so this is what the version of the spectral sequence says. So sometimes this statement here, so this is this is convergence of the spectral sequence. Okay, so here this is the same thing as the following. It says that EIJ of R converges to, and then this is equal to some crap. And so this comes from a computation. This converges to if I take the associated graded of cohomology, we take the ith graded piece. Okay, the last thing I guess I forgot to tell you was what the definition of the associated graded is. So I said I have this induced filtration. Did I tell you what the induced filtration is? I didn't tell you what the induced filtration is. So before I do this, I'll come back to that in a second. The induced filtration is quite stupid on cohomology. So we're given this K with its filtration, and then so this is this decreasing filtration, and we define. Let me see where it is. Well, I'll just say what it is. The induced thing on, let's say, the pth piece of HN, okay, of K bullet. So this is applied to here. So this is equal to, well, this is just equal to the image of HI. So I told you that this guy was a subcomplex, HN of FP K bullet. So now I said that this was a complex in HN K bullet. Okay, so this makes sense. And this actually defines the filtration. Okay, so now if I go back to here, let's see, one more. Okay, so now the general shape makes sense. So I have some induced filtration, and the induced filtration will be computed by something explicit here, and this is what we're after. Okay, and now let me show you what one of these looks like, and let's do it for the Hodge filtration. So this is what I call this is what's called the Hodge filtration, or Hodge to DeRom. Okay, I haven't defined algebraic DeRom. There'll be some other video on the definition of the DeRom cohomology, but I mean most people know this. I mean not most people. Most people don't. I don't know if most people know this or not. Let me say what this looks like in this particular case. So so what does it say? We are going to have this I j, and then we take. So do I want to do it in this note? Okay, I'll do it in both. I'll do it in most. So this is Hodge. So this is the standard form. Or standard notation. The standard notation doesn't tell you. It doesn't. It just says that. I don't know. I don't really. I'm not a fan. X omega I x over s. This thing converges to. Do I have room? H I plus j DeRom of x over s. And then there's the today's version form. What I said before is that, okay, so this thing has, this DeRom cohomology has a filtration on it, and what we can do is we can take the induced filtration on the nth cohomology, the nth DeRom cohomology, okay, and then we can look at the associated graded piece. So what I'm doing here is I'm actually only getting a chunk of this cohomology. For the DeRom cohomology, it's a little bit special, but in that you can get more than just a chunk. But in general, you'll just get a chunk. And it says that here that this is equal to h n minus I omega I x over s. So this is, so I said that when you do this, you're going to have something explicit, some crap, and the something explicit is this here. So this is the explicit stuff. Okay. Let me say some more. So in order to make sense of this statement, we need a filtration. So the filtration, okay, so the filtration on the complex in this example so there's actually two filtrations you can do. It's the stupid filtration. And let me just say a little bit more about what this is. So, or I should say, it comes from the it comes from the stupid filtration. Okay, and I can see what this means. So we talked about that. Okay, so the stupid filtration, so we have our complex. So the DeRom complex. Okay, so this is for sheaves, okay? And this looks like this thing. So we have the sequence. Like so. And what you can do is we can define f, let's say, P stupid of this guy. Okay, and what it does is it gets rid of everything all the way up to the pth piece. Okay, so it just kills everything. And actually, when we look at in our guy here, so this thing, the definition of this is actually in terms of hypercohomology. So so we have this, and so this thing actually induces F stupid a filtration on this guy here, DRAM. Let's do this on not on this. Well, it does induce a filtration on theirs, but first on the double complex. Okay, this is painful to write, but I'm gonna do it. R that we have omega, let's say S x over S. So we have this thing, and so this is where the so-called total complex of this guy is the underlying complex of of DRAM cohomology. Algebraic, let's say algebraic DRAM. So it's funny because we have the DRAM complex, and the DRAM complex isn't actually the complex that gives you DRAM cohomology. And the filtration on the DRAM complex isn't the actual filtration that you use the Hodge to DRAM spectral sequence. Okay, but anyway, you'll get a filtration here. It induces something on this thing that we use to compute DRAM cohomology, and then we actually have our filtration. Okay, so let me say a little bit more. What's still mysterious is what these EIJ things are, and you know what they do and how you get them.